Hi guys, and welcome to IndusCore Tech, where industrial engineering becomes simple. Here we break down robotics, automation, sensors, control system, and real-world industrial technology with clear visuals and practical explanation. If you want to understand the core of modern industry, you're in the right place. So let's start. Every industrial machine depends on one thing, and it's the information. But where does this information come from? Today we're exploring the core component that makes automation possible: sensors, detectors, encoders, and the signal they generate to communicate with control system. So, what is really a sensor? First of all, it will capture what its environment offers. It has a data as an input, called physical quantity, as a force, temperature, or pressure, and as a result you will get a signal as an output, and it can be an analog signal, a digital signal, or an on-off signal. So to start, we will explain what's a signal, and then I will explain the three of these things. Let's go. So what is a signal? A signal refers to any voltage, current, or time varying electromagnetic wave that carries information, and you have two kinds: analog signal and a digital signal. So for the first one, we will find a continuous signal as shown in this graphic. We will find a time domain signal, and the last one, the frequency domain signal. And for the second one, you will find an on-off signal, a pulse signal, and for the last one, simples. So what is the transmission of a signal? Signal transmission refers to the transmission of data or commands from one point to another within the system. And how does it work? So from one side you have the digital signal, and in the other side you have analog signal. So for the digital signal, it's simple. They carry coded data, bits or bytes, and it requires a protocol, depend of the technology or the industry. So you can find, as an example, the I2C, SPI, CAN, LS485, Modbus, SSI, Indot, and Profinet, EtherCAT, etc. And for the analog signal, so the analog sensors do not use a communication bus because it's use the form of a proportional electrical signals. And you can find the analog voltage transmission, the analog current transmission, and the analog transmission via impedance variation. So now let's start with the analog voltage transmission. So as an example, you have the 010 volt or 15 volt. It's used for temperature, pressure, level. The advantage of this technology, it's simple and easy to transmit. The disadvantage, it's sensitive to interference, signal loss over long distance. And for the analog current transmission, as an example, you have the 420 milliampere. This is the industry standard. It's used for pressure sensors, humidity transmitters, and flow sensors. The advantage, it's very low sensitivity to interference, no voltage drop, long cabling possible, and wire break detection. And for the last one, analog transmission via impedance variation, this is the raw signal from passive sensors. So next I will explain what's the difference between passive and active sensors. So they modify the resistance, the inductance, the capacitance, or generate voltage, and it requires a signal conditioner as a Weston bridge amplifier or an AC excitation for inductive sensors. So in the industry we hear a lot of people talking about sensor, detector, and encoder. They have the same purpose, but what's the difference between them? So here I created a table of criteria to make a comparison between the three of the subjects. So at the left side we have the information, signal type, function, and example. So we will start with the sensor. So the information that we'll get from it, it's a measured value. The signal type can be an analog or a digit signal. The function, it's the physical measurement, and as an example of a sensor we have the PT100 as shown in this image. And for the detector, it's just detecting the event. So it's just a 1 or 0, a high or low signal, it's yes or no. So the signal type is an on-off only. The function is binary detection. And as an example, we have the sensor, the inductive sensor, this one. And the encoder, we have a coded position or speed. The signal type is always in a digit because it contains bits and bytes, so it's a pulse. The function is a position encoding, and as an example, we have the incremental encoder 1024 points, as shown in this image. So here comes the classification. So there is the passive sensor and the active sensor, but what's the difference between them? So an active sensor requires to generate its signal. So what does it require? It requires a power supply, and the characteristics of an active sensor is that it's integrated in electronics. So what does this electronics provide? So it will make you and create you a direct signal that you can use without like creating your proper stuff, and it's of course more precise. And as an example, you have the pressure sensor. So the piezoresistive with amplifier that will quantify the pressure. You have the ultrasonic sensor, the HCSR04, that will quantify the distance. The gas sensor, the MQX family, so it's for the concentration of gas. The MEMS accelerometer, so the ADXL345 for the acceleration. The optical sensor, that is an amplified photodiode for the brightness. The next one is the passive sensor. It does not require any external power, so it simply changes an electrical property when it undergoes a physical change. So it uses the resistance, the voltage, and the inductance to create a signal. So the characteristics, it works by modifying the RSC natural generated voltage, does not produce a signal on its own. So you need to board your stuff, you need to have a Whitestone bridge or an amplifier to detect a proper signal. And as an example, you have for the resistive, you have the NTC PTC thermistor. So it's quantify the temperature. You have the direct piezoelectric. So the sensor is a quartz sensor, and it will detect the shock or the vibration. You have the passive inductive LVDT coil, and it's for the displacement. And you have the photoresistor, as an example, the LDR, and it's for the light, to detect the light. So now we will explain the passive detector. So it's very rare in the industry, and it only works if an external phenomenon produces a signal without a power supply. So as an example, you have the reed switch that does not require a power, just a magnet. So here you have an open contact, and when you approach the magnet, the contact will close, and this is how it looks like. This is a reed switch. Then you have the active detector. It's very common in the industry, and as an example, you have the inductive sensor, the capacitive sensor, and the photoelectric sensor. The next one is the passive encoder. So it's non-existent in the industry. Some resolver can be considered passive, but this is not common because they are driven by an external signal. So what's the difference between an encoder and a resolver? So here you have two images, at the left the resolver and at the right the encoder. So the resolver will get you an analog output, and the encoder will get you an digit output. So there is a lot to say about them. Maybe we'll make a video and make a comparison between them. So just a little tips: the resolver can work in a harsh environment in the industry, and it costs less than an encoder. And now you have the active encoder. So this is the case in the industry. That requires a power supply, 5 volt, 12 volt, 24 volts. And as an example, you have the incremental encoder, the absolute encoder, and the optical or magnet encoder. So thank you for watching. If you want clear and practical knowledge in automation and industrial engineering, make sure to subscribe and like the video below. See you in the next lesson. Thank you and assalamu alaikum.